The tallest building ever constructed by humans is the Burj Khalifa building. It is a true feat of modern engineering, standing firm on loose, sandy soil and withstanding the fierce Arabian winds. But because of its distinctive style and hybrid form, it stands out as a multifunctional building that showcases Dubai's diversity and positions the city as a leader in the business, tourism, and construction industries. In this video, we'll examine every engineering architectural detail of the tallest Burj Khalifa building in the world, beginning with its straightforward hexagonal core. Let's dive straight in. Hexagonal core. The RCC constructed core keeps the Burj Khalifa balanced and allows it to remain standing in the face of Dubai's destructive windstorms. The building's entire lift system is also supported by the hub. The Burj Khalifa boasts the fastest lifts in the world with the longest travel distance. Podium. By serving as a base and anchoring the tower to the earth, the podium permits on-grade access to the building's 3 levels from 3 separate directions. Separate entries are provided for the corporate suites at B1 and concourse levels, the Burj Khalifa residences at ground level, and the Armani Hotel at level 1 by fully glazed entry pavilions built with a suspended cable net structure. Buttresses. A solitary core like this one could have collapsed at any time due to its extreme instability. Support is required for this single core to remain stable. The creative solution provided by engineers is akin to the buttresses that give dams their strength. These buttresses holding up the dam wall against water pressure must have been visible to you. Similar buttresses hold up Burj Khalifa's hexagonal core. Buildings are always vertical and never sloping, isn't that right? They incorporated a step-shaped design into the buttresses to make the towers surrounding them useful. This is the primary plot twist. The buttresses were engineered in such a way that you could live next to them and never even know they were there. The Burj Khalifa's architects also made effective use of this area for corridors, allowing people to move between the buttress walls and their apartments from a lift. Huge glass facades that encircle the buttresses were designed by the architects to provide all of the hotels and living areas inside with an amazing view from every angle. These cross walls and columns provided the support these glass facades needed. Floor mechanical. The machinery that powers the Burj Khalifa is housed on 7 mechanical floors, each rising to a height of 2 stories. The mechanical floors, which span 30 stories, contain the electrical substations, water tanks and pumps, air handling units, and other crucial parts for the tower's functionality and occupants' comfort. Steel superstructure. The superstructure is made of steel. Large reinforced concrete mats that are supported by board-reinforced concrete piles underpin the superstructure. Extensive seismic and geotechnical studies served as the foundation for the design. 12,500 cubic meters of concrete were used to build the 3.7-meter thick mat in 4 separate pours. The piles, which have a diameter of 1.5 meters and a length of 43 meters, are the biggest and longest that are typically found in the area. To reduce any negative effects from corrosive chemicals in the nearby groundwater, a cathodic protection system under the matte and highlight density low permeability concrete were used in the foundations. What's interesting is that while the Burj Khalifa primarily resists bending, the top of this superstructure is permitted to bend and sway by roughly 6 feet during windy storms. The remaining 25% of the structure is made of steel and does not have any concrete core support. Although it may seem excessive, steel is capable of withstanding tensile loads with ease. Therefore, in the event of an earthquake-like oscillation, don't panic. It's likely just the Burj Khalifa waving hello to the winds. The hexagonal core can withstand the twist and shear stress brought on by wind because of the reinforced concrete. Because of its incredible buttressed core system, the Burj Khalifa is referred to as a wind-stiffened rod. Vortex shedding. The tower's form and details were greatly influenced by the integration of wind engineering concepts intended to confuse the wind, or vortex shedding. These included the stepped spiral's direction being reversed to face the dominant wind and the scallop-hip buttresses' shape softening. Spire. The Burj Khalifa's telescopic spire, which is made of more than 4,000 tons of structural steel, is its most notable feature. The spire was built from the inside of the structure and used a hydraulic pump to raise it to a height of more than 200 meters or 700 feet. The spire not only cemented Burj Khalifa's title as the highest building in the world, but also gave the landmark a sense of completion as part of its overall design. There is also communication equipment housed in the spire. Wind tunnel tests. The structure was put through more than 40 wind tunnel tests to see what impact winds might have. These tests included determining how the building would fare in Dubai's climate and how well the design would withstand wind in areas with microclimates, like the terraces. Wind tests were even conducted with the cranes positioned atop the tower to guarantee that the proper safety measures were implemented at every stage of the building process. Additionally, tests were conducted to make sure that pressure and temperature variations at high altitudes were taken into account during the building's design. Lightning arrestor. Two of the Burj Khalifa's engineering marvels are a lightning rod that was modeled after a spider lily, and an inventive way to raise concrete in the hot climate of Dubai. The Burj Khalifa took 6 years to build and used special concrete and engineering to overcome height restrictions. Plumbing and electrical. The architect, structural engineer, and other consultants worked together to develop the mechanical, electrical, and plumbing services for the Burj Khalifa in a coordinated manner during the design phase to achieve maximum efficiency. Every day, the water system of the tower provides 946,000 liters, or 250,000 gallons of water on average. Burj Khalifa will need roughly 10,000 tons of cooling during its peak cooling period, which is equivalent to the amount of cooling that 10,000 tons of melting ice could provide. A substantial amount of condensation is produced by the building's cooling requirements and Dubai's hot, muddy weather. This water is gathered and emptied into a holding tank in the basement parking lot via a different piping system. A year's worth of supplement water from the condensate collection system is roughly 15 million gallons from 20 Olympic-sized swimming pools. The peak electrical demand of the tower is 36 megawatts, or roughly 360,000 10,100 watt bulbs operating at the same time. Fire safety. The Burj Khalifa was designed with fire safety and evacuation speed as top priorities. All of the stairwells are surrounded by concrete, and the building's fireman's and service elevator, which will be the tallest service elevator in the world, has a 5,500 kilograms capacity. There are pressurized, air-conditioned refuge areas about every 25 floors, since it is not realistic to expect people to walk down 160 floors. Exterior cladding, reflective glazing, textured stainless steel spandrel panels, and stainless steel vertical tubular fins make up the external cladding. The Burj Khalifa's external cladding is made up of nearly 26,000 hand-cut glass panels. For the tower's cladding project, more than 300 Chinese cladding experts were brought in. The cladding system was tested in dynamic wind and water conditions using an engine from a World War II aircraft to further ensure its integrity in the face of Dubai's intense summer heat. The Burj Khalifa's curtain wall is the size of 25 American football fields or 17 football fields, soccer. Today's towering Burj Khalifa is a tribute to the amazing efforts of architects and engineers who surmounted numerous structural and practical difficulties. Their ingenuity is demonstrated by its tapered and angular design, which was specifically designed to withstand strong winds. It was their inventiveness and use of novel methods that enabled them to build this enormous glass and steel titan. To say that Burj Khalifa represents the state-of-the-art in building design would be an understatement. From the beginning to the end, significant technological advancements, along with creative structural design techniques, have produced an efficient and sturdy superstructure. If you like the video content that we provide on this channel, please feel free to leave a comment below. Hit the like and subscribe buttons for more videos. See you in the next videos.